Scene opens with a sweeping aerial view of Boston Dynamics Robotics campus. Inside, pristine clean rooms buzz with robotic arms and engineers working diligently. Narrator VO. In the heart of cutting-edge robotics innovation lies a machine designed to redefine mobility and adaptability. Spot. Boston Dynamics' groundbreaking quadruped robot embodies decades of research and engineering mastery. Its creation is a testament to human ingenuity and the drive to push technological boundaries beyond what was once thought possible. From concept sketches on engineer screens to the precise assembly of intricate parts, every step in Spot's manufacturing journey reflects an uncompromising pursuit of excellence. Today, we delve into the meticulous process that brings this mechanical marvel to life. A journey that blends advanced materials, precise machining, intelligent software, and visionary leadership. Cut to design rooms where engineers sketch and model robot parts. The journey begins long before any metal is cut. Teams of engineers and designers collaborate to develop detailed computer-aided design models. Every joint, actuator, and sensor housing is painstakingly crafted in virtual space, tested through simulations, and iterated upon to optimize performance and durability. This digital blueprint ensures that the final product will operate seamlessly in the complex environment Spot is destined to explore. Extensive testing simulates the wear and tear Spot will endure, from dust storms to heavy rain, extreme temperatures to physical impacts. Each batch of materials undergoes rigorous scrutiny to ensure they meet Boston Dynamics' stringent standards for longevity and reliability. Footage shows CNC machines meticulously shaping components from raw metal blocks. Once the designs are finalized and materials approved, manufacturing moves to precision machining centers. Here, computer numerical control CNC machines carve components with micron-level accuracy. Each motor housing, joint bracket, and frame piece is crafted to exact specifications. Robotic arms assist in transporting delicate parts through multiple machining stages, ensuring repeatability and reducing human error. Assembly technicians wire actuators with sensors that measure position, force, and torque in real time. This sensory feedback is critical for maintaining balance and adjusting movement dynamically. Each actuator undergoes bench testing, simulating the stresses it will face during locomotion. Engineers carefully assemble legs, integrating wiring harnesses, sensors, and actuators. Spot's legs are marvels of engineering, housing complex assemblies of motors, encoders, gyroscopes, and force sensors. Each leg integrates multiple degrees of freedom, enabling a range of motions including stepping, climbing, and crouching. The integration of these components requires extreme precision. Engineers use specialized jigs,